Okay, we're going to be studying normalization, and normalization is basically a design process in which data inside tables is separated into several tables. So we start off maybe with one table. So we start off with that one table and we break it into several tables, okay? And there is a process, there are some rules according to which we decide when to separate tables. Okay, now those rules are basically called the first normal form, the second normal form, and the third normal form. And these normal forms, these processes are applied in a sequence, which means what? If you have a table and you want to normalize that table, you're going to first apply the first normal form, then the second normal form, and then the third normal form. So this is the sequence that needs to be followed. And these are some of the advantages of normalization. It improves performance. Primarily, it reduces data redundancy, and by data redundancy we mean unnecessary copies of data, multiple copies of the same data. You try and reduce that, because if you are saving that same data at more than one place, then you are eating up disk space, and you don't want that. So the advantages of normalization are that the performance is improved, faster sorting, faster index creation, less chances of data inconsistency, and reduced data redundancy. Just memorize these advantages. We are now going to take this table called booking as our starting point and start normalizing it. Remember, normalization is the process of breaking data into separate tables. These tables are related to one another. This table, as you can see, has 3 records, and each record, so like one record, has several fields like the booking ID, venue name, venue address 1, venue address 2, date, band name, number of members, and headlining. Now each field in a record must have atomic values. Atomic values are values that cannot be divided. Let me explain what atomic values are. For example, consider the name of a person, John Doe. John Doe is not an atomic value, even though this is the name of a single person. We can actually logically divide it into 2 parts, first name and last name. And because this name can be divided into 2 parts, it is divisible. Therefore, John Doe is not atomic. So this is not atomic, because we can break it into 2 parts, and this is atomic and this is atomic, right? So we've split this name, which was not atomic, into something that is atomic now, right? So these values can now not be divided any further on a logical basis, right? So this is an atomic value, and this also is an atomic value, and this was not an atomic value. So if we want to enter this name in our database, then we must create a table with 2 fields, first name and last name, and enter this name as atomic values, right? So this is the solution, right? Okay, now let's take a look at the booking table and see if we can find any problems with this table. If we take a look at this record, straight away we can see that there is a problem. The band name does not have atomic values. In fact, it has 2 separate values. We can logically divide these values into 2 parts. We can say that this is the name of the first band, and this here is the name of another band. So these names belong to 2 different bands, right? So this may be one band, and then this may be another band, right? So this may be another band. So logically we can divide this information into 2 parts. We can say that these names belong to 2 different bands. Therefore this value is not atomic, and this problem also exists with number of members, and this problem also exists with this field called headline. In short, the values in this field and this field and this field, they are not atomic. Collectively this group with these three fields is called a repeating group. This is called a repeating group. Why this is called a repeating group is because if we were to rearrange these values and save them as atomic values in a new table, then we can see that this set of values right here, this set of values 105 ABC Theatre, Campsite, CA 2306 2016, right, this set of values keeps getting repeated for this table buzz and the ITWIS. Previously it was like this. Now we've split this up into two records, right, one for this and the other one for this, right. So we've split this up into two records and we've saved these values atomically. We can see now that the band name has buzz, so this is an atomic value, it only belongs to one band, and we've saved this as ITWIS in a separate record, and this is also an atomic value, right, it cannot be further divided. But now we have a problem, right, this set of values right here gets repeated, right, and it is getting repeated because of this repeating group, so the set of values gets repeated because of this repeating group. So now with this table we have some other problems. There is data duplication. We can see that the same data keeps getting repeated, right. Additionally, booking IDs are primary key, and we can even see that primary key values are getting repeated 107, 107, 107. So even this design is not acceptable. By the way, this view of the table, right, this view is called the logical view of the table. So this is the logical view, and this shows all the data entries inside of it. Without the entries we can show our table design like this, right. So this is the definition of the table. The name of the table is booking, and everything within these parentheses here, these are the fields, right, booking ID, venue name, venue address 1, venue address 2, and so on. All of these fields have been included within the parentheses. Booking ID, because it is the primary key, it has been underlined. Now what we are not showing here is the repeating group. So how do we show this repeating group, right, this repeating group in this definition, right, in this definition of the table? And the way to do that is to include an inner set of brackets, right. So we're just going to put an inner set of parentheses, an inner set of brackets around the repeating group. Okay, so what is an acceptable solution? How can we redesign so that we do not have any of these problems anymore? The solution is that we are going to apply the first normal form. We are going to break this table, booking, into two parts, right, and the way to do that is that we are going to separate the non-repeating group of attributes and the repeating group of attributes into two parts, right. So we're going to separate them into two parts. Applying first normal form, we've broken this single table into two tables, right. The non-repeating group of attributes, we've given that table the same name, booking, right. So we're sticking with the old name here, but this table, which has been created from the repeating group, we need to give it a new name. So for this new table, we must keep a few things in mind. There are a few steps that we must take. This table must be given a new name. We must link this new table to the other table, right, to this other part, right. So we must link these two tables together by adding a foreign key, to this table, right. And finally we need to choose a primary key for this table. So we must ensure that all of these three steps are carried out for this table that we've created from the repeating group of attributes. Okay, so let's apply all of these 3 steps to our new table. We're going to call our new table as the band booking table. So the name that we're going to give this table is going to be band booking table. So that's step 1, right? And the second step is that we have to add a foreign key to this table. We have to add a foreign key to this table. Remember, the foreign key is always selected from the other table, and from the other table we are going to always select the primary key of this table, right? So we're always going to be choosing the primary key from this table to become the foreign key in this table, right? So here's what we're going to do. We're going to add a foreign key to this table, and we've completed step 2 now. So this booking ID is basically the foreign key, right? So this is the foreign key for the band booking table, right? Now that we've done step 2, the third step that is very important that must be implemented is choosing a primary key. So we have to choose a primary key for this table, right? That's the third and the final step. What I'm going to do is, for this band booking table, I'm going to show you the logical view of the band booking table. That way it is going to be easier for us to select the primary key. And we can see from the logical view, from the entries inside of this table, we can see that none of these fields is unique. When you take a look at booking ID, it is 105 here and 105 here. So it's the same value, so primary key must be unique, so booking ID cannot be the primary key. Likewise, band name, you can see buzz here, and buzz here, so even this field is not unique, so this cannot be the primary key. Number of members is also not unique. We can see that these are the same values. Likewise, headlining is not unique. These are the same values. So none of these fields individually can be the primary key. Alright, if none of the fields in our table can be the primary key, what is the solution? One solution is to add a new field and use the new field as our primary key, such as the serial number, and ensure that serial number is going to be unique. The second solution is to look for a combination of more than one field and see if that combination is unique. For example, is a combination of booking ID and headlining unique? So is this combination, booking ID and headlining, is this unique? If we take a look at this record, we see that 106 is the value of the booking ID and the value of headlining is N. If we take a look at this record, once again we get 106 and N. Clearly this combination is not unique because we have found this in multiple, we found the same value in multiple records. So this field, so the combination of booking ID and headlining is not unique. Therefore we cannot use this combination as a primary key. Let us now try and take a look at the combination of booking ID with band name. If we take a look here, we see 105 and buzz, and when we take a look at all the records in our table, we'll see that this value does not get repeated again. Okay, so let's just check one more time. Let's take a look here, and in this entry we can see that the booking ID is 107 and the band name is ITWiz. If we search our table for this combination and see if this value gets repeated anywhere in our table, we see that this value does not get repeated. So booking ID and band name, this combination can be used as a primary key. So this combination can be used as a primary key, booking ID and band name. So this time we are going to have a primary key that is going to be made up of more than one field. Such a primary key is called a composite or a compound primary key. Compound primary key. Finally, this was the original table, right? So this was our original table, right? And then we applied first normal form to this original table.